Okay, let's begin. So, starting a different topic. It's called marginal functions. So, it's mostly applied in economics application of derivatives in economics. Okay. So let's talk a little bit about what are marginal functions and how do we apply them, how do we use them. Here's the idea. Suppose, motivating example or whatever. Suppose we have a cost function, say c of x. So it tells you the cost to produce, say, x items. Now, if we find the derivative of the cost, right? How can we compute that? Well, by the definition, it's going to be the limit as h approaches 0 of c of x plus h minus c of x all over h. Now, here's what we're going to do. What happens is that, remember how the derivative was actually working? It was when we took the slope of the secant line, and then we slowly closed the distance. And the smaller the distance got, the more the slope of the secant line would converge to the slope of the tangent line. That's how we actually found the slope of the tangent line. Okay? So, one way to look at this is that your derivative is approximately the same as just the c of x plus h minus the c of x all over h when h is small. Whatever that means, in some contexts, close to 0 is what we mean. So the closer your h gets to 0, the closer this expression will get close to this expression. Okay? Now, in many economics contexts, h equals 1 specifically is considered small. In many contexts, h equals 1 is pretty much the closest you can get to 0 without actually being 0 itself. So normally if you're a manufacturer, you're producing a certain amount of products. What is the smallest amount of products you can produce? Well, 1. Right? No one's going to say, oh, we produced half a product today. That's not really a thing. 1 is going to be pretty much the smallest thing you can produce without producing nothing. Right? So now, oftentimes what would also happen is that you're a manufacturer, you're manufacturing thousands, millions of products potentially, right? So you're building iPhones or whatever, right? You're making a lot of them. One iPhone, not a big deal. One iPhone, no iPhones, nothing. It's essentially 0. So there are contexts in which h equals 1 is considered small specifically, and plugging in h equals 1, we get this expression. The derivative of the cost function is going to be approximately equal to c of x plus 1 minus c of x, of course divided by 1. And this is the main equation where the whole idea of marginal functions came about from. Now, question to the class. The right side of that expression, what would you say that represents? So remember, specifically I'm thinking of C as a cost function. In words, how would you express what this is actually trying to calculate? C of x plus 1 minus C of x. What is that? Question should probably end with a question. Yeah, so take a look at this right side. What would you interpret that as, yeah?
Is it the rate by which it's changing? Like how many products are being?
That's how I would interpret the left side for sure, because it's a derivative, it's a rate. But let's say, no context, I just told you this, C of x plus 1 minus C of x. What would you say that is giving you, this subtraction? What is that subtraction telling you? How would you be able to interpret that? I mean, what is C of x plus 1 telling you? How would you interpret that? C of x plus 1.
It's the function where all the x's are x plus 1.
Specifically in this context, C of x means cost, right? So C is a function. C of x is cost to produce x items. What is C of x plus 1? Yeah?
The cost to produce x items plus 1.
So this is the cost to produce x plus 1 items, right? This guy here is the cost to produce x items. What is the difference representing? Yeah?
Is it the profit?
Well, no, in general, profit is revenue minus cost. I mean, we'll talk about that pretty soon. So revenue is how much money you make. The cost is what it costs you to make that money, how much money you have to put in. Revenue is how much money you get out. And of course, the difference is what your profit is. So it doesn't have to do with profits. We're still focused on just cost here. So cost to produce x plus 1 items. And that's the cost to produce x items. If I subtract them.
How much it costs to make one item?
How much it costs to make one item. Exactly. But not quite. Not necessarily. Which item are you talking about here specifically? The first item, the second item, the third item? This is the cost, or maybe it's better for you to think of it as the additional cost to produce one more item at what point? Well, after X items were already produced. Right? Now, cost is a strange thing. It turns out that depending on what level of production you're at, costs might rise, they might actually fall if you're producing more things. So it's not just the cost of one item, because producing your first item is very different from producing your 100th item, right? You don't expect the cost to be the same. So for example, to produce one iPhone, what would that actually take? You have to have costs to actually build a factory, hire people, you have a bunch of things would go in. If you want to just make one of them, there's a bunch of things that have to go right. Now if you want to make two of them, is it going to cost the same amount of money? Well, no, because you already have the infrastructure, you already have a lot of things. Making your second iPhone is a lot different from making the first one. And making the third one is a lot different from making the second one, right? So I'm not just talking about the cost to produce one more item, cost to produce one more item at a specific point after X have already been produced, right? So this is going to represent the cost, the additional cost of producing one more item at a certain production level, right? So I might ask the question, okay, we've already produced 100. What would it take to get 101, right? Or we've already produced 1,000,000. What would it take to get 1,000,001, right? That's kind of the question that you want to ask, right? So yes, it's going to be the cost to produce one more item at a certain level of production, right? And what you will notice here is that that thing, whatever it is approximately equal to the derivative of the function, right? So, i.e., this is what's called the marginal cost of production at the margins, right? This would be the economics term, right? So you're at the edge, okay, we're at this end point. What would it take to push past that margin? Okay, we produced 1,000 items. What would it take to push past that to get to 1,001, 1,002, right? So this is talking about the cost at the margins. If we're at a current level of production, if we're stretched ourselves as far as we can currently, what would it take to go a little bit more, right? That's the kind of question that you want to answer. And to answer that question exactly, you would actually compute this expression. I want you to note, this is approximated by the derivative. And so that leads to what's called a marginal function, right? So a marginal function is actually just another name for the derivative. But when you call it a marginal function instead of calling it the derivative, it means you're thinking about it in a certain context. This leads to the fact that marginal cost would, if you look at the marginal cost function, this is considered to be the derivative of the cost function. And so this is going to be a function that tracks your cost at the margin. And the derivative is the derivative. And it turns out the derivative of the cost function is approximately equal to the cost at the margin. And so it's called the marginal function. The idea is computing the derivative at a point can be easier than actually computing the right side of that equation. And so what you can do is, if you know the derivative of something, you can use that to track how things will happen at the margins. And this idea is applied in general. So if f of x is some function, then f prime of x is called its marginal function. So if you have, say, p is profit, then if you find p prime, you found what you call the marginal profit function. Or you can say R is revenue. Then R prime is the marginal revenue, etc. Right? No matter what the function is, if you're thinking of it in an economics context to talk about what's happening at the margin, the derivative is what's going to tell you what happens at the margin. And it comes from the idea of just kind of relaxing the strictness of the derivative definition to think of 1 as being almost 0. Because in business context, 1 is almost 0. Right? So that's the idea. That's where the idea of a marginal function comes from. It's the fact that we can use the derivative to actually track how much is it going to take to get one more of these items, given the fact that I have made X items so far. So the additional cost, or the additional profit we can make, or the additional revenue we can make. So this is the context. This is what a marginal function is. It's basically just another name for the derivative. It's exactly the derivative. It's just that when you use the word marginal, we're now thinking, okay, we're talking about economics now. And that's basically it. So this is going to be an application of derivatives, so it is going to be a word problem type-ish kind of thing going on. And because I'm too lazy to actually write out all the word problems, I put them on some handouts. So give you some handouts for these topics. This is already on the class, an electronic version. This is already posted on the class website, by the way. So the first part was kind of talking about the discussion that I had with you guys earlier, so you can ignore that. So the important part is what I basically just wrote down here, the definition. What does it mean to be a marginal function? The derivative is the marginal function. So C prime is the marginal cost, R prime is marginal revenue, P prime is marginal profit. And this is what they approximate, the cost to produce one more item, and then I gave some examples of what that would mean in this context. The kind of question that you would use a derivative to answer in an economics context. So that's the first page. So we have a couple of examples on the next page, which we're going to go through. And but just to make sure, because we're not assuming too much, because understandably, not everyone will know about the economic functions. So FYI, some background things. If we talk about cost, C of X, when it comes up with a cost function, it's very rare that you're going to be able to create one from scratch, right? So this function will tend to be given. Because it depends on too many things, depends on too many things. Things that you wouldn't be able to, sitting down with a pencil and paper figure out, right? Depend on your location, the market, your advertising, how many people you're hiring. It would depend on things information that you won't know how to deal with without actually going in and doing research, right? So the cost function is going to be given. You don't have to worry about coming up with a cost function, right? So if you ever need to use a cost function, I will tell you what the function is in the problem. So that's the first thing. When it comes to revenue, revenue is the Rx function. This is often a common way to talk about this is the price per item times number of items sold. Right? So I open up a hot dog stand, I sell it for $2 a hot dog. If I sell 5 hot dogs, I've made a revenue of $10, right? So I sold 5, that's the number, and the price per that is $2. $2 times $5 is $10. I would say my revenue is $10, right? So revenue is just price per item times number of items sold. This is pretty much how much money you make. How much money made from selling a product or service. But specifically, we ignore cost here, ignoring costs. Right? So I'm talking about how much money I make. I'm not going to talk about how much it costs me to make that money. Revenue is just about purely how much money you make, right? From you selling this product or service, how much money did you actually bring in? So that is what we call revenue. It's just how much money is made, ignoring all costs to make that money. Another important thing is profit. Now, profit we'll often abbreviate with P of X. And profit is going to be revenue minus cost. So remember, the cost function will tend to be given. It's not something you'll know. It will depend heavily on context. And revenue, though, you're going to know how much money you're making. You know how many products you sold. You know what price you sold them for. You'll be able to figure that out with this equation. If you take the amount of money you made and subtract the cost it took you to make that money, how much did you have to pay in rent? How much did you have to pay in salaries for the people you hired? How much did you have to pay for advertising or whatever? How much do you have to pay in taxes after you sell the products, right? That will all go into your cost function, right? So once you take the amount of money you made, you subtract the cost it took you to make that money. What's left over is called your profit. That's how much money you take home at the end of the day. That it's all yours. You don't owe anybody anything. That's what's called profit, right? So this is just the revenue minus cost. So those are the main functions. You might also have something called a demand function. So there are also functions called demand and supply. X. This is, it describes price consumers are willing to pay. Per item. So I can talk about, so this is just a function that describes price. But it describes price from the consumer's perspective. There's also something called a supply function. Now, we're not going to go as deep into these as you would in an economics class, so don't worry too much about that. I'm not going to talk about law of supply and demand or anything. We're just going to talk about, you need to know what these functions are, and then we're going to examine them in terms of their marginal functions. There's a supply function, this is often called S of X. So this also describes price at which suppliers are willing to produce an item. So this is usually described in terms of price versus number of items that could be sold at that price. So the thing is, for demand function, put price here and number of items. Demand functions will tend to actually fall, right? They'll tend to actually be decreasing functions. Why? Because if you raise the price, people are going to buy less items, right? Like you have a lot more people buying Toyotas than you have buying Ferraris, right? That actually makes a lot of sense, right? Because this is cheaper, more people can afford it, so the number of things you can sell at a lower price are going to be higher than the number of things you can sell at a smaller price. But if you wanted to know specifically, if I set the price to be $20, right? How many products can I expect to sell at $20? So you might say, oh, I expect to sell 100, right? So, and that again, the demand function is also going to be given because that's not something that you can actually predict. Sometimes it just takes a lot of research. So a lot of times what people will do is they'll do their market research. They'll actually sell the same product at different prices in different locations. And then they'll actually track how many products they sell. And then they can say, oh, over here, if I sell it for $20, we only sold like 15 products per week. While over here, I sold it for $22, but I actually sold 52 products in this week, right? So they do their little tracking and they come up with a little function that describes, okay, setting a price at this much, we can expect to sell this much, right? And that would be the demand function. So. And you can have supply function. Now the supply function actually rises over time. So if you talk about the price, and this is from the producer's perspective, the supplier's perspective, number of items. Right? So if you come to me and you're like, you know what, I'd like you to build me an iPhone, I'll give you $20 for it. Like, I got stuff to do this week and whatever, I'll pay you $1,000 for it. I can make 10 of them by next week, right? The higher price I can charge, the more I'm willing to produce because that's more profit, that's more money, right? So the supply function tends to rise over time. And of course, this is getting way too far into economics because we're not going to actually talk about this ever. The sweet spot is where these two guys cross. That's called market equilibrium. So you want to find the perfect price that people will buy it from you, and at the same time producers are willing to produce that amount. If you are below that, you will have a shortage of supply, you will have more people are willing to buy than there are products in the market. Beyond that, you will have just a surplus of things because you would have less people willing to buy, but you have more products out there. So you try to kind of find the sweet spot. And marginal functions, when it comes to all of this, kind of help us do that. We kind of can predict, if we're to push the margins a little more, what's going to happen? Are more people going to demand it or less people are going to demand it? Right? The marginal cost or the marginal demand, the marginal supply, these are all important for that kind of question. If we were to push things a little further, if we were to do a little more than we're currently doing, what is going to be the response? Right? That's what we want to try to figure out. And it's also worth mentioning, FYI, if demand is given. So sometimes a problem would tell you straight up, this is the price, we're selling it for $5 and that's it, we don't care. But sometimes someone might take the market into account, and in which case you will talk about your revenue in terms of the demand function, the price that we can sell X items at, and then you multiply that by X. Right? So it's the same kind of idea here, price per item times number of items sold, where X is the number of items sold, but the price is determined by this function. So a more sophisticated way to do a revenue function would be technically the demand times X. Okay, so just a crash course in all these economic functions. These are the guys you need to know about. Cost and demand, they're going to be given, you don't have to worry about them. Supply, we hardly ever do any calculations from the supplier's perspective, really. Unless we actually care about the market equilibrium, we're not really going to focus on that. We want to focus on what can we sell things for, how much revenue would we make, how much profit would we make, what's the cost going to be. And then we're going to use the marginal functions to talk about, okay, if we push it to one more, what's going to happen? Right? Are we going to make money, or are we going to lose money? That sort of thing. So that's the general idea, just some general principles here. We're not really going into anything in any more detail than that. When it comes to the kinds of problems that we need to be able to solve, these are some examples, right? So in example 1, let's actually go through example 1 to it's kind of a introductory example so you can kind of see how these things fit together. So we'll work through this one. Okay, so suppose the cost of producing X glow in the dark, it's called the dark box issue. Okay, is this. So in problem 1, I told you the cost to produce glow in the dark box shorts. C of X is equal to 2x squared plus 3x. And of course, yes, in real life, your cost function is never going to be that easy. It's not going to be a quadratic or something silly like that. This is just to show you an example of how you would look at these things. Okay. So A asks for, what is the additional cost? To raise production from 10 to 11. So that's the actual cost that we want here. B. What is the marginal cost? when x equals 10. And the idea is I want you to notice that those two things are in general very close to each other. And of course, 10 is like nothing compared to the scale that we're normally looking at, right? So if these two things are close, it's actually pretty remarkable in and of itself. Right, so A. So if I know I've produced 10 and I want to know what it costs to produce 11, what am I looking for? Yeah?
You just plug it into that equation.
Yeah. So what do you want to plug in?
10 first and then 11 and then find the difference.
Okay. Cost to produce 10 of them is going to be what? Well, it's going to be that. So that's going to be what? 230. So I know what's in those boxer shorts, but that's a lot of money to produce 10 of them. Okay. What about 11 of them? It's 2 times 11 squared plus 3 times 11 plus 2 times 121 plus 33. That's what? That's 242 plus 33. Is that? Is that 275? Is that right? So this means the cost to go from level 10 to 11 is going to be C of 11 minus C of 10. That is going to be 275 minus 230. That is going to be 45. Okay? So someone comes like, yo, we've already made 10 of these boxer shorts, we're getting ready to ship them. Should we make an 11th one? Think it's going to be worth it? Now you're going to think, well, how much would it cost me to make the 11th boxer shorts, right? $45 is what it's going to cost. Now, unless you're selling it for a lot more than $45, probably not going to make any sense. But that's what it's going to cost to make the 11th one. Now, if I ask you the marginal cost when x is 10, what am I asking you for here? What does this ask you to calculate? Yeah?
The additional cost to produce one more after 10 boxers.
Yeah, but how do we find
Use
marginal cost?
C prime x.
So we look at C prime, which is,
C x plus 1 minus
no, the C prime, right, the regular C
Oh.
prime.
2,
Or that.
2 times x plus 1 squared. Okay.
Come in. This is C right here.
Yeah.
What's C prime?
Okay, 4x plus 1.
Now, so that's the marginal cost. If I were to find the marginal cost at 10 items, what would be the result? 43. So, here's the scenario in this case. We want to find the additional cost to produce one more item, given the fact that we've already produced 10. We have a couple options at this. We can actually go through all the minutia of actually figuring it out exactly, or we can just make a guess with a very simple one-line kind of thing, right? Right. So you look at all the calculations here, and then you look at all the calculations here, and it kind of tells you that I'd rather do this than have to do all of this, right? So that's the first thing that you want to notice. Second thing that you want to notice is that these two are pretty close together. We're only off by $2, right? So this guy here is like, I could do this calculation a lot quicker, a lot easier, and yes, it's a guess. It's not going to be exactly what the answer is, but of course, I mean, in business, even if you're not going to measure things exactly anyway, it's going to give me an approximation of the answer, but it's a quicker way to get to that approximation, and it's not that far off. So, I mean, probably 3%, 4%, something like that. So, not bad for the derivative. So, and again, this is just from 10 to 11. It's not a lot, right? We really want to get to a point where 1 is almost like 0. Now, compared to 10, 1 is not close to 0 at all. That's like really far from 0. But it still gave us an answer that was pretty close. And you can even talk about going even farther. If you go to like from 1,000 to 1,001, you'll actually get even closer to the answer percentage-wise. So that's just an example of how you use a marginal function. So that's why they're nice. Instead of doing all of this, you can just do this. And you're going to be off by a little bit, but usually it's not going to be like, oh my god, we can't really do anything. And the thing is, in the real world, cost is approximate anyway. You know, things happen, and you don't ever actually spend exactly how much you think you're going to spend. So you're going to go do all those calculations for something that's going to be an approximation anyway, if you really think about it. Marginal cost, nicer way to get to a guess for what this would mean. So if I want to go from 10 to 11, all I do is find the marginal cost at 10. That's going to tell me what the 11th one would cost me in addition to this. So that's an example, just to show you kind of overall how they're used, what the benefits of using the marginal function is versus the actual function, and to kind of show you, even at small production levels, you're not off by that much. Stay for home team. So in example 2, I told you a demand function. So I told you a demand function, which I call P for price. That's just little p. Is 25 over square root of x. So that's the demand function. So this basically tells me the price at which people are willing to buy items. X is the number of items that I can sell. So to sell one item, I should set the price to be $25, right? If I want to sell 100 items, I should set the price to be $2.50. This is the function that's going to tell me how to set my price so that I sell the amount of items I'm willing to produce. Okay, so that's the demand function. Now, A. We want to find the marginal revenue. Now, of course, before we find the marginal revenue, we need to find the revenue, but that's the first thing we're going to want to find, the marginal revenue. We're then going to want to find what is marginal revenue when x is 100, and interpret what that means. And if someone told you the cost, see, we're given now that the cost to produce x items is x squared plus 2x. Again, very simple. Find marginal profit. Now, of course, to find marginal profit, you're going to need to find profit. Then, D, find marginal profit when x equals 100. Interpret. And essentially now, E, going to find out, is it worth it? Meaning, if we're at 100 items, does it make sense to actually produce one more? Alright, what do you think? How do we do this? How would you do A?
Would you put in one, since revenue is the price per item times the number of items sold?
So revenue is price times number of items, right? What's the price here?
25. Well, 25.
Well, no, it's not 25 over X. So the number that you're selling, the price is gonna change based on that number. Times, how many things are we selling? Well, X of them. So my revenue function is 25 radical X. How do I find the marginal revenue function? Yeah?
You just put in 100.
No? So this is revenue. How do we find marginal revenue?
Derivative.
It's the derivative. What's the derivative of that? Yeah?
Add 25 over 2x.
25 over 2x. That's your marginal revenue function. Okay. How do you know what the marginal revenue is when x equals 100? Well, you plug in 100, of course, right? So this means r prime of 100. This is 25 over 2 times the radical of 100. That's 25 over 20. After that goes 5, after that goes 4. So that's pretty much 1.25, or you can think of that as $1.25. How do you interpret that number? The marginal revenue at 100 is $1.25. What does that mean?
Okay, how much money was made after 100 pieces or 100 pieces?
What do you mean after 100 pieces?
After 100 pieces, what do you mean?
Well, the expected increase in revenue to make specifically one more after 100, to make the 101st product. Okay. So after we've already made 100, how much additional money do you expect to make if we were to make 101? We'll get an extra $1.25. Okay. Now if I told you the cost, how do you find the marginal profit? Of course, to find marginal profit, you need to find profit. So how would you find profit?
Subtracting the cost by revenue.
So profit equals revenue minus cost. Do we know the revenue? Yeah?
125. Or is that? Yeah, it's 125.
No. 125 is the marginal revenue at a specific point. Do I know the revenue function?
25 over 2 square root x,
No,
or square root x.
this is the marginal revenue function. Max for the revenue function.
Over square root of x. It's not,
No, that's right.
oh,
Revenue function, R of x equals that. And the cost is this, so I'm gonna subtract that. So my profit function how would I find the marginal profit? Derivative. That is the marginal profit. Finish up the rest. Tell me what you think on Friday. Is it worth to keep going? That's pretty much this topic. Next time, next time. Gonna do another set of work models. I should probably give you those guys. You can read this over for next time. Try to finish those up.